A projectile is launched with a speed of v0 at an angle of alpha with respect to the incline. The angle of the incline is beta. The projectile lands on the incline in such a way that at the instant that the projectile strikes the incline, its velocity is perpendicular to the plane of the incline. So this path is at right angles to the plane of the incline. We have to find the relationship between alpha and beta in order for the projectile to strike perpendicular to the incline. Now the flight time of a projectile on an incline we know as 2v0 sine of alpha over g cos of beta. Let's mark this as equation 1 and use it in our further steps. Now observe the net velocity of the projectile along its path. It is always tangential to the path. And at the point where it strikes the incline, its velocity vector is perpendicular to the incline. This would mean that at the point where it strikes the incline, its vector component of velocity along the x-axis will be 0. The entire velocity is perpendicular to the plane of the incline, and its component parallel to the incline will be 0. And we will take advantage of this. Let's focus on the x-axis, which is along the plane of the incline, and pay attention to Vx, the x component of velocity along the path of the projectile. Vx begins with an initial velocity of v0 cos of alpha, and all the way it remains parallel to the plane of the incline, but its magnitude begins to reduce. Make sure that you are clear about this. The x-axis is along the incline. If we are taking the component of this velocity parallel to the ground, then it would have remained unchanged. But along the incline, it would keep changing due to the acceleration g sine beta being present along the incline. Now watch how Vx changes till it strikes the incline. And Vx reduces down to 0. And finally, as the projectile approaches landing, this component Vx is 0 along the x-axis. The initial velocity is v0 cos of alpha, and the final velocity along the x-axis is 0, as we had discussed, due to the perpendicular landing. The acceleration is minus g sine beta along the plane of the incline or along the x-axis. Let's plug this into the first equation of motion along the x-axis or along the plane of the incline. This gives us the time t as v0 cos of alpha over g sine beta. Now this time t is the same as the time we obtained in equation 1, since this also represents the time of flight of the projectile. So let's equate equations 1 and 2. Equating equations 1 and 2, we obtain the following relationship between alpha and beta. 2 tan of alpha equals cot of beta. So when this condition is satisfied, the projectile will land perpendicular to the plane of the incline. As long as this relationship is maintained between the angle of the incline and the angle of launch with respect to the incline, the projectile will always land perpendicular to the plane of the incline. When a projectile lands perpendicular to the plane of the incline, its velocity component along the plane of the incline at the time of making the landing is 0. The entire velocity is perpendicular to the plane of the incline.